What is up, YouTube? Welcome back to another episode on Code with Annie. And in this episode, we're going to take a look at the second sorting algorithm on our playlist, which is going to be insertion sort. Now, this is also an in-place sorting technique, and I'll tell you how this one works. In this particular video, I'm just going to show you the algorithm. In the next video, I'll show you how you can write the logic for insertion sort in Java. Okay, so without further ado, let's get started. Insertion sort basically does an in-place sorting, meaning what it does is it considers this entire list, okay, and it sees that the first element during the first pass is always sorted. What I mean to say is it starts the sorting from the second element. It assumes that the first element is in the current position. So what I mean to say this is, say by this statement is the entire array in insertion sort is logically subdivided into sorted and unsorted halves. And during the first pass, insertion sort assumes that the first element is in the sorted position. Assume that sorted positions are on the left side and unsorted ones are on the right side of the array. Now, it assumes that 30 is sorted. So during the first pass, that is the first iteration, the result is going to be the same as the original array, which is 30, 5, 1, 22, 19. Now, what happens in the second iteration is, or second pass, is it will compare 5 with 30. Okay, it will see that 5 is less than 30. Once it finds that an element is lesser, because we're going to sort it in the ascending order, once it finds that there is an element which is lesser than the first element, which it considered to be in the right position, it will swap that element. So the result of the second pass will be 5, 30, 1, 22, 19. Observe that once I find out with 5 and I compare 5 and 30, I will not go to the next element. Once I do one swap, I end that pass and I come out of it. So second pass is going to be nothing but 5, 30, which is considered to be in the sorted position, and 1, 2, and 19, which are considered to be unsorted. Always note that it operates on the logical partitioning of sorted and unsorted. Okay. In the first pass, it said that 30 is sorted, 5, 1, 22, and 19 are unsorted. Now it has observed that 5 and 30 is sorted, 1, 22, and 19 is unsorted. Okay. Now, third pass. Now, here is where things become a little interesting. What happens is, now 1 is taken as the next element for comparison, and 1 is compared against 30. And we see that 1 is less than 30. So, in third pass, it says 5, 30, 5, 1, 30, 22, 19. And then immediately it will compare 1 with 5 as well. Why? Because now the sorted side has two elements. Initially it had one element. The moment the sorted side increases with the number of elements, for example, there are two elements here, the unsorted elements which you pick up subsequently have to be compared against all the sorted elements, right? So you picked up 1, you compared it against 30, and you did a swap. Now, during the third pass itself, you'll also compare 1 against 5, and you'll see that 1 is still less than 5. So during third pass, it will do one more swap, and it will say 1, 5, 30, 22, 19. This will be the final outcome of the third pass. Now note that at the end of the third pass, your sorted size is 1, 5, 30. Your unsorted are 22 and 19. Now, during fourth pass, what we do is we pick up 22. We compare 22 with 30 first. What is the value of 30? 22 is less than 30, right? So it will become 1, 5, 22, 30, 19. Then again, you will compare 22 with the next one, right? 22 with the element 5. 22 is not less than 5, and 22 is not less than 1. So your swapping will stop right there, and this is the final outcome, which is 1, 5, 22, 30, and 19. This is the end of fourth pass. Also note that in the end of fourth pass, these 4 elements are sorted. Only this one is unsorted. Now in the fifth pass, what we'll do is we'll take 19, we'll compare against 30, and we'll swap it. We'll say 1, 5, 22, 19, 30. Okay. Then subsequently, we'll see that 19 is also less than 22. So we'll do one more swap. So this becomes 19 and this becomes 22. Okay. And subsequently, we'll also see that 19 is not less than 5, not less than 1. So with this, your sorting is ended. And if you look at this elements in the array, right, at the end of fifth pass, it's 1, 5, 19, 22, and 30, which is exactly sorted in ascending order. Notice that there is a difference between the earlier sorting technique, which I explained, which is bubble sort versus insertion sort. The difference is you start from the second element, you assume that the first element is already in sorted position, and then you compare all the elements in the sorted position with the single element from the unsorted side. Okay, 5 is compared against 30 because that is the only element in the first pass, right, which is considered to be sorted. And then you end the pass and you come to the second iteration wherein you pick up the next element, which is 1, and now you have 5 and 30 in the sorted position. Therefore, you compare 1 against 5 and 30. Subsequently, 22 is compared against 1, 5, and 30. All three of them. So you pick up one element from the unsorted side and you compare it with each element on the sorted side. Note that the comparison also has to go in the order in which, in the precedence order, meaning when I pick up 1, right, I will not compare it with 5. I will compare it against 30. I will do a swap and then I will compare it against 5 and do a swap. Okay, maintain this order of reversal. So if this position, let's say, is 0, 1, and 2, you pick up 2 and you will compare it against 2 minus 1, which is position 1, and then you will compare against the position 0. Okay, always go in the order. Swap and then do the comparison. Don't keep comparing. So let's say I compare 1 with 30. I know that 1 is less than 30. I will do the swap, and then when I am done with the swap, I know that my elements are now like this. Then I will compare 1 against 5. Okay, it's very important that this technique follows this pattern, which is compare, swap, and then compare, swap. So it goes on like this. There is not going to be comparison simultaneously, or there is not going to be swap back to back. It's always going to be compare and swap. Okay, keep that in mind. And the other important aspect is pick one element from unsorted side, compare with all elements of sorted side. In this case, initially you had only one element, then it starts increasing, right? So you will have to compare against all the elements. Just you have to pick up one and you have to compare against all of them. And the end result is this. So this is called as insertion sort. If you do like this video, hit the like button, subscribe to CodeWithAni if you haven't already. And I'll give you a homework exercise. Try to see if you can write the Java code for this particular logic. If not, as well, no worries. I'll help you guys write the Java logic for this one in the next video. So do share it with your friends, and I'll see you guys in the next one. Bye-bye.